All right. This is the most important video, in my opinion, in all of the Svelte 5 videos. Or, I mean, this concept is just vital, and it's something that isn't really emphasized in the docs. Maybe it is now, that now at the time that you're watching it, but at the time that I'm recording this, they don't really talk about it. So, the microtask barrier. So this is kind of a thing. I call it the microtask barrier. The term microtask is legit, but I call it a barrier. But so, okay, how to explain this? So basically, in Svelte 5, well, in JavaScript in general, there's this API. It's about microtask, and there's this function called queue_microtask. And what that function does is it essentially um, it creates a queue_microtask. Let's see, here we go. So basically, what it will do is it takes a function and it will run that function. What is the official thing? It will run after the current task has completed its work and when there's no other code waiting to be run before control of the execution context is returned to the browser's event loop. Okay, it's a long sentence. What's it saying? In JavaScript, there's this thing called the event loop, which you can think of as almost like the heartbeat of your application. It keeps running to see if there's something else to do. So you can think of it like this. Imagine you're looking at a screen. Let's say this one. Right now, there's probably some things going on in the event loop. There might be some trackers, some APIs being, uh, uh, fired every now and then. But in a simple website, there would kind of be nothing happening until I interact with the screen. So I might hover over this. Maybe that hover would create some JavaScript. Um, it would call some function or something like that. The moment that happens, it's the event loop that puts something in the I forgot what it's called. It's not a stack. It might be a stack. Anyway, it says this needs to run now, and the processor will basically grab it and say, okay, I got this, and it will create what can be referred to as a synchronous context. So it'll just run through all of that code until it gets to the end. So it'll go through that function. If there's functions in there, it'll open them, and it'll continue to go through all the code until it pops that last function, which might have been, let's say, an event listener, a callback in an event listener. It'll pop it off, and then it'll step back into the event loop, and it'll be like, okay, I'm ready for the next thing. There might not be another thing, but it's still ready. And that's the event loop. And the thing about this event loop is that it doesn't interrupt when things that are running synchronously. Like, this is why when you create a promise, for example, a promise with a callback, like, you can't just run that promise in the synchronous context. You can't just say, okay, bring in the promise now, like, it's resolved now, put it in here. Well, you kind of like, I mean, that's the idea with awaits and then, right? With awaits or then, you're basically saying stop here and wait for the event loop to continue. But you're actually not stopping there. And that's an important thing. You're not actually stopping when you use await or when you use then. The synchronous context is still going, but you just took a callback function and put in the event loop, and the next time whenever that promise is satisfied, that function will come around and be like, okay, let's run this now. Anyway, the point is, queue_microtask. What queue_microtask does is it basically says run this function right as you're finishing this synchronous context. So right as you're finishing it, you're about to glide right into that event loop to ask for the next thing. Nope, not quite yet. There's this microtask, and that is where effects live. So whenever you have an effect, whenever you call an effect, with the exception of effect.pre, which is a little bit different just on the initialization, but I'm going to go into that later. That's probably next video. But effects are basically created after the microtask barrier. So what that means is that everything that's run, actually, let me show you. Okay, so I created this little script here. I put a nice little header. Don't do this. Don't do this. This isn't what you should do. And I'm going to explain why you shouldn't do this. What's going on here? We have a count, it has a state. We have a double. The double has a state. This effect is basically saying, oh, by the way, if you're kind of coming in this video without having watched the previous two, if any of this is like kind of confusing, I would recommend going back and watching those. But yeah, anyway, I'll continue now. So yeah, so the double will basically, this effect will run when count changes, and it will assign the double to it. Now let's just look at the output here, because it's good to get to know this stuff. Ignoring all the HTML stuff, let's just look at the, so this is the inc function, and it has this internal function called update, which basically adds 1 to count. It's one of these like, yeah, like if I did count equals count plus 2, it's gonna basically, here, this might be clear. So update is kind of a shorthand thing, but here we're setting count to what we get from count plus 2. And then here's an effect that we're setting double to whatever count is times 2. And so this is double. And then these template effects, they're basically, this is an effect that is basically reactive to count, and this one is reactive to double. And it's all inside this template effect. And we're going to be going to a little bit more of the different kinds of effects in a future video. But for now, just it's kind of good to look at this a little bit for 2 reasons. One, you know your framework, but also what we're going to be writing in my framework, which has the visualizer, so you can see the states and deriveds and effects and how all that's working live. It's written in something similar to this. So anyway, we'll see that when you click this button, it works. So you think, well, what's so bad about it, right? Well, what's so bad about it is that you are not, if you think about what's running, and here's the best way to do it, right? If I put console log double, what's going to happen? That's weird, right? Let's do that again. So count equals count times 2. So if effect is reactive to count, and it changes double to count times 2, and then we console log double after, why are we getting 0, right? Shouldn't we get 4? Or to make this even more, what's this going to happen, right? Count is 2, but double is 0. Why? Why is that happening? I'll tell you why. Actually, do you know why? Yes, that's right. The microtask barrier, we didn't cross it yet. So we need to cross it before the effects will run. And that's what happens, right? So you had a state, and the state changed, and the state marked an effect as dirty. And then when we hit that microtask barrier, when the microtask was done, or rather when the synchronous context was completed and we're about to go into the event loop, then we fire the effects. Now, when is this taking place? This is before the microtask barrier. So we got the updated count, right? Because the count stuff, the states, are before, right? But the effects are after. And if you see this question mark here, where it has that question mark after that, the reason why that question mark is there is because we don't actually know, like you can't know what an effect is going to do, right? You can know, like, okay, you got to think of it like this. So you have states. States have reactions, which is the inverse of a dependency. So a state can mark a derived as dirty, or it can mark an effect as dirty. If you're a derived, you can mark a derived as dirty, you can mark an effect as dirty, but you also have dependencies, which might be deriveds and might be states. If you're an effect, you can only be marked as dirty. You can't mark other things as dirty. You can only do things. And the things that you do will always happen after this microtask barrier. So this is why it's really important to understand this. And again, this is something that I kind of wish they would emphasize more in the docs, and hopefully they have by the time you watch this video. But because in the docs they just say don't do this, and they don't really explain why. But the idea is, whenever you're working with states and deriveds, you can always be guaranteed to have the latest value. The moment something happens on an effect, you know you're pushing it off to later. For all intents and purposes, it's kind of like a promise, like you're waiting for a promise to resolve, or like a timeout, a 0 millisecond timeout. So we've got we got here, and you'll see as we go down, it will always have the previous value, right? Because it's still waiting for that microtask to finish. Well, it's not waiting, that's the problem, so it gets the old value. Now watch this. If I import this little handy thing called tick from Svelte, and then I say tick, then, and I put it in here, make that nice and neat. Okay, run. Oh, look, now it's updated value. So I hope that kind of goes without saying what tick does. What tick does is tick basically is a promise that will resolve after the effects have run, which means not just when we've crossed the microtask barrier, but when we've crossed the microtask barrier and have ran everything that needs to be run, and then we're ready for the next, event or something. Yeah, so that is basically, what else should I add here? Right, okay, so how do we do this properly? I mean, I think it's pretty obvious, right? But I'm going to do it anyway. We don't need tick. We just make a derived, or, right, as I said last time. In the previous video, I spoke about how we don't need to use deriveds, really. We can just call functions that return states, and those functions, just because they access a state, whenever they're evaluated, they're reactive by nature. But with the derived here, derived cant x2, let's put double, right? Get rid of all this. Oh, no, not ink. Not ink, not this. Let's say do this. How about this? We don't need tick anymore, right? Don't need tick. Okay, let's try it out. Yeah, there you go. And so here's basically the thing, right? So in this synchronous context, right, we say that deriveds are lazily evaluated. That means they're only evaluated when they need to be, right? And sometimes they don't need to be until after this microtask barrier, right? But other times they do. So how does that work? Okay, so here's a little, here's a depiction of a counter. Now I think there might be some logging going on here, not sure. No. Refresh. So I'm just gonna let's go into the code first. So this code here, I might have mentioned this before in this video, I'm not 100% sure, but this code is based on what the Svelte 5 compiler compiles to. It's not the same. It works pretty similar. Like, I tried to get it to work almost identically, at least from all practical perspectives, like not including some optimizations and stuff. But as far as the things that you need to think about, or it would be helpful for you to think about as a Svelte programmer, it covers all those. Yeah, so basically, this is just, I'm just going to go through this code real quick just so you know what we're looking at. This is just a little thing that I wrote to just get, it's a little convenience thing to get elements and stuff. So let's see, so we get the button from this, then we add a listener, and every time we click, we set counter to the get counter +1. Now, Does that look similar to what we looked at earlier? Should probably ring a bell. Then we get all the spans, and then we do this thing called effect.pre. Now, effect.pre is something I'll get into later, but basically it's a special kind of effect that for now, what it does is it just runs synchronously on the first initialization, and actually everything involving rendering tends to work like this. But again, I'll get more into that later. But yeah, so what it does is it sets the count span inner text to the counter. And then there's another effect which has nested effects, which is something you can do. So we have the double span inner text is sets to the double. And if it's double, then we remove this span, or remove a class from something. I actually don't really remember. Is there something that happens here? Oh, it was more than 20. Okay, yeah. Okay, so I think if we watch this, we can figure it out together, because there's actually been a while since I wrote this. So let's increment. So as you can see what's happening. Okay, let's pause it. Increment. What just happened? We're freeze framing, right? Now, I didn't make this so that the synchronous context has, like, you can't pause the synchronous context, but you can pause at the microtask barrier and every effect that's run after that. So what just happened here is we just pressed increment. So let's see. So is this the one? Click. Increment button, yeah. So we set counter to get counter plus 1. Now what's counter? What depends on counter? Well, let's look here. So double depends on counter, and double is a derived. This counter text display, which is the 6 right here, also depends on counter. And immediately, there's 2 levels of dirtiness that counter is kind of propagating out. There's dirty and maybe dirty. And you can see this if you look into the Svelte source code. This might not be exactly how it works, but it's pretty close. So everything that is just an immediate reaction, so things that immediately depend on it, they don't go through a middleman, little deriveds in the middle or anything like that, will be marked as dirty. And that's symbolized by this black. So it's like the blue text means maybe dirty, and then the black around it means definitely dirty. So this counter text display is definitely dirty. This double is definitely dirty. And then everything else that is connected to that is marked as maybe dirty, because double, it might change, but it also might not, right? It will definitely need to be reevaluated, but it might not change. Okay, so let's go next. So now what we do is we process the maybes. And as you just saw there, the double was evaluated. And basically this effect was marked as dirty. So if you saw the double actually change its value, it changed from 12 to 14. And because it changed, now this was marked as definitely dirty. If it didn't change, it would have been marked clean. It wouldn't have run again, right? Next. Then there's this process of organizing the effect tree, which is basically a way to prevent redundant operations from happening. So basically what that means is if you have, actually, I'll show you in a second after, because I think this covers it. So we applied the effects here. We applied the counter text display, so that changed to 7. And the next one we applied the double text display, that changed, and then we're good to go, right? So let's just keep doing that. I'm gonna unpause this so you can just see it happen live. Everything's happening live. Okay, wait, let me restart that because over 20. So we go to 20, let's pause it, let's do it again. Okay, same thing as before. We got our double, that's dirty. Our counter text display, definitely dirty. Then we got some maybe dirties. Um, if you notice here, the blue lines represent the hierarchy of effects. So I probably should have mentioned this earlier. The um, the red lines represent the reactivity graph, but the blue lines are different. The blue lines represent the ownership of effects. So you have an effect root, and the effect root can have children that are effects, and those children can have children that are effects. Um, and if you think about it, if an effect, let's say if like the leaves are the most outward effects, and then there's branches, and then there's the root, right? The the branches, like if a leaf and a branch, if they're both marked as dirty, well, it wouldn't make sense to run the leaf and then the branch, because the branch by its own nature would end up recreating the leaf anyway, right? Because it'd have to be rerun. And so what happens is there's kind of a culling, and it will not run effects that it detects have a parent effect that's going to rerun, right? So here we have more than double and double text display. No, I'm going to run this through. I just want to make sure I'm narrating it properly here. Let's go. Okay, there we go. So you process the maybes. The double, here, actually, yeah. So the double changed to 22. And then the is double more than 20 changed to true. And so now we have this more than double and this double, which has a child, this double text display. And so basically what happens is it's going to organize the effects now, and it's going to say, oh, well, actually, we don't need to run the double text display, because when we recreate the more than double, it's going to have to recreate this anyway, right? So it kind of smartly organizes things in such a way that you're not doing repetitive tasks. Okay, next. More than double. Okay, so we just changed the counter. Now, more than double, trigger that. Uh-oh. And watch this. This double text gets garbage collected. I don't know if you caught that, but it faded away. Double text display is double. What just happened? Things just moved around. I didn't quite catch it. So I think what says uh-oh? Yeah, so this is hidden. So it's basically when it is double, it removes this class. It removes the hidden class from the warning span. But anyway, that's kind of like, I hope you're kind of beginning to see the how this reactivity graph works. By the way, this kind of software here that I made, it's available. It's open source. You can play around with it. I put the documentation on. It's not totally complete. I think the documentation is still from kind of an older iteration of this, but it should still work. I mean, everything that I put in this video will work. But yeah, so let's just kind of recapitulate. I really like that word. So the most important thing in all of Svelte, microtask barrier, right? Effects run after the microtask barrier, which means that state, derives, all this stuff, all of that can be run synchronously. And whenever you're in here, no matter what you access, you're always guaranteed to have the latest value. So always, 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 if you can, use deriveds instead of effects. If you're using an effect to change a value, use a derived instead. It means you can use a derived instead. And I guarantee you, because a lot of people come from these backgrounds where it's all about effects, and it doesn't matter. But like, the truth is, it's not, like, it can lead to so many annoying bugs if you use effects where you shouldn't. And probably most of the time when you make those bugs, you'll be like pulling your hair out, trying to understand where the bug is. But if from the start you just made sure that everything that you wrote that wasn't really that didn't need to be an effect, to use it derived instead, you would have been good to go. So try to keep everything that you can in the synchronous part of this, and the effects, just like my rule of thumb is like API calls, DOM manipulations, um, things like that. There are use cases, there are edge cases where you would want to use effects to change, values, or exclusively so. But like they're very rare, and you'll know if you come across one. But for the most part, it's really important to understand this. The other part of this is the derives not having side effects. You don't want deriveds to have side effects in them. And the reason why you don't want them is because they're lazily evaluated. So, so basically, what happens is that a derived might not even be called if, like, for example, let's say this purple one was in here. If a state changed, this derived changed, this derived would be marked as dirty, but it would never run. If there was nothing asking for its value, it would stay dirty. It would stay dirty indefinitely, but it would never run. And so you don't want to have side effects in your deriveds, because if you think that they're just going to run whenever the state updates, and I did touch on this in an earlier video, they're not just going to run when a state updates. They're only going to run when they need to run. So in an earlier video, I talked about how deriveds, because of the way the runtime reactivity works, deriveds won't change just because in your code there's a signal in there and that signal might have changed, because the derived might not actually be reactive to that signal at the time. So that's one reason why it might not run. The second reason is because, it's possible that the whatever it depended on, it was evaluated and it found out that it didn't change. That's another reason it might not run. And then another reason, the third reason it might not run, is because there's nothing depending on it. And so don't think that just because you put something in a derived, like you do derived.by and then put a function in, and you think, oh, when this changes, I want this to change. And you think that you're just doing a clever thing where you're just like kind of reaching on the side, side effecting. Don't do that. That's not a good idea. If you want to do a side effect, there's a rune for that. It's called effect. So use that instead. But yeah. So next video, I'm going to be talking a bit about the effect tree, about effect pre, and how effects kind of work. And I think that's probably going to be my last video for this series. Let's see. Yeah. Hope you enjoyed this. Hope it was helpful. I will say I do think this is the most important, least talked about aspect of Svelte 5 that will create the most gotchas. So yeah, see you in the next video maybe, but